Hello everybody. Today we're going to be talking about more trig derivatives. So we're basically going to be expanding on the rules that we've talked about a few weeks ago. The two rules that you guys should know by now, d dx of sine x. Remember, this just means the derivative. So the derivative of the sine of x is cosine x, and the derivative of the cosine x is negative sine x. We went through these a few weeks ago, but we'll go through a few easy ones before we move on. Rules you should always remember at this point. Product, quotient, and chain. I'm not going to go through them because you just spent last week reviewing them. We're going to start with a problem that we've already done before, but I think it makes sense to start with this type of problem. Let's say I'm given f of x equals tan x, and I want to find f prime of x. Let's go back to our roots for a second. Anytime we're not sure what the rule for the derivative is, here we have concrete rules, we know what they are, we have to kind of start by doing this. Our definition of the derivative. Limit as h approaches 0 of the function tan x plus h minus tan x over h. And if you were going to plug 0 into this function, you see you get a 0 on the bottom. So basically what this would entail is we'd have to rewrite this, and we'd have to make some substitutions with some identity rules. And to tell you the honest truth, it's going to be a huge mess. So let's go back to our function and see if there's other things we can do. So we look at tan x, and what's the first thing that comes to your mind? Well, can't I rewrite tangent x as sine x over cosine x? And now, since I know the rule for each one of these, and I know the quotient rule, I can go ahead and substitute this in. Bottom, derivative of the top, minus the top function, derivative of the bottom, over bottom squared. And this just takes a little cleaning up. Cosine squared x minus negative sine squared x gives me a positive. Oops, look at what I did. I don't have you guys in class to stop me. Negative sine squared x all over cosine. Now, if I have cosine x squared, I can write this as cosine squared x. Okay, that's something that you guys should know how to do. And if I look up top on here, I have sine squared plus cosine squared, so that really is a 1 over cosine squared x, or another way I could write this is secant squared x. So we can basically say, now we have one more rule. The derivative of the tangent function is secant squared x. Okay. Let's just work through a few simple examples, and then we'll get on to more complicated stuff. This is very straightforward and easy. Remember, if we're going to take the derivative, we just go one term at a time. This 3 is really just a multiplier, so this becomes 3 cos x minus 2. The derivative of cosine is negative sine. And you should clean this up. 3 cos x plus 2 sine x. And that would be your answer. That's how easy it is. We start by looking what our function is. So I have two terms. One of the terms is going to involve the product rule. No problem. Negative 12x to the negative 5th. Minus, now here you could do this a couple different ways. I usually just start the parentheses and apply my product rule. First, the derivative of the second, well, we just established the rule for that, plus the second function times the derivative of the first. Now what we want to do is we just want to clean this guy up. Now, I know I tell you always write with a positive power, but we're just going to leave that alone because I just want things in one line. Now I would distribute into my parentheses. Minus x squared secant squared x. Now here this gets tricky. Minus. Now this 2x here is really what we call a multiplier. It's not part of the angle portion. So I'm going to take this 2x and move it out front like I have it over here. And there you have it. That's your answer. I'm going to skip over number 3. It's just a little time consuming. So I'll let you practice that one on your own if you want, because I don't really have any practice problems for you today. And this is the answer you should get. Okay? So this one is just practice on your own. And now let's look at 4. I don't think I gave you anything like this. Not quite sure. Can't remember that far back, a few weeks ago. But look at what's going on here. This is cosine of x cubed. Okay, so my x is still just a nice little angle there, but I have it being cubed. So basically, this is really a very, very easy chain rule. Whenever I have something raised to a power, I take the derivative of the outside, and then I take the derivative of the inside. And now I would probably go and kind of write this a little nicer. This would be -3 out front. I like to put my signs first. I don't know why. And this becomes cosine squared x. And there you have it. There's your rule for the derivative. Okay. Now we're going to look at some problems that get a little more complicated. First, I want to kind of walk through some notation with you. d dx sine u equals cosine u du dx. d dx cosine u equals negative sine u du dx. d dx tan u equals secant squared u du dx. This all looks a little bit scary. Don't stress out about it. Don't worry about it. Let's think about this. Okay. So what is u? U is just a way of saying something is just more than x. So this just means instead of just having an x in my expression, I might have something a little more complicated. So it's going to complicate the derivative process. Du dx is just another way to say u prime. So basically, d dx sine u is just going to be cosine u times u prime. And same is going to hold true for each of these. So even though it looks very, very scary, when we get to, when we do a problem in just 1 second, you're going to see it's not all that scary. Okay. Everything we do in this class, if you break it down into its pieces, is manageable. So we're going to work through these 4 examples. Find the derivative. So y equals sine 2x. First thing I look at it, I have something more complicated than just an x. So I think to myself, I'm going to use u's. If you want to, when you're first doing these, so the derivative of sine would be cosine u times u prime, right? If y is sine u, the derivative is cosine u, u prime. So let's now, y prime is going to be cosine, my u is just 2x, and now u prime, I'm looking right here, right? If u is 2x, u prime is just 2. And that's the rule for your derivative. If y equals sine of 3x squared, now look, this is my u. Once again, y prime is going to be cosine u times u prime. Y prime is cosine, u is 3x squared. Now u prime, I'm just looking in there, is 6x. And we're always going to move that multiplier portion out in front of the trig function. Y equals cosine of u squared. So I'm going to look at this just for a second. So I have u squared. Okay, so I'm still dealing with u is going to be 3x squared this time. So y prime is going to be, the derivative of cosine is negative sine u times u prime. Y prime is going to be negative sine, my u is 3x squared. So now u prime, if you want to work it out on the sign, that's fine. 2 times 3x times the derivative of the inside, 18x. And we're just going to always make this what I call math pretty, right? Multiply any loose ends together, sine 3x squared. And our last problem of this nature, cosine squared 3x. Now this one's going to be a little bit of a challenge. First thing I'm going to do is rewrite this guy like that. So basically, I have a u, I have something being squared, but I also have a u in there. So this is sort of a double chain rule. I'm going to start outside, so I'm going to take the derivative of the outside function. Remember, when we use the chain rule on a set of parentheses, leave the inside guy alone. 2 cosine to the first power. Now work inside. Now I have cosine u. So this is going to be negative sine u times u prime. So I have 2, negative 1, and 3. I get a negative 6 out front, sine 3x, cosine 3x. So these may seem like a bit of a challenge to you guys. That's why we're doing this at the end of the year in a very, very relaxed environment. Just because it's some good stuff you should see before you enter into a calc course. And I highly recommend you keeping these sheets that we're working through right now for next year. All right, so now let's talk about this. What's the difference between a function and its derivative? We've been talking all year long how important it is to know what function you're dealing with. It's going to become extremely important as we move to calculus types of problems, which this is. A rodeo performer spins a lasso in a circle perpendicular to the ground. The height from the ground of the knot, measured in units of feet in the lasso, is modeled by this function. First of all, when I look at that function, it just hurts my head. But we have to learn to not be afraid of things like that. T is measured in seconds after the lasso begins to spin. So I have time, I have height. Okay. So I kind of know that the h of t, that's my height function. So we want to first find the value of h of 0.75, and then I want to, using correct units, explain what this value represents in the context of the problem. Get used to seeing this in a calculus problem. They always have you do the math and then explain in words what it means. So it's going to, that's the challenge next year, okay, after we get over this challenge. Find the value. Well, this just means what? Plug this in. We want to do h of 0.75. We're just going to plug this into the function. Now, basically, hopefully by now, whenever you see a pi, you know that you should put your calculator in radian mode. So the first thing I'm going to do is make sure my calculator's in radian mode. Now, I pretty much have gotten in the habit of, whenever I'm working with a calculus problem, I put that function in my calculator because I'm not quite sure what I'm going to be asked to do. And it just sort of makes things, I get to see a picture and whatnot. So I'm going to look at this graph. Here's my knot. My knot is going up and down and up and down and up and down. We want to know at 3/4 of a second, right, or 0.75. That I'm not quite sure where it would be on the x-axis, but we want to know what the height of it is. If we want to plug something into our function right from our calculator, we have 2 ways we can do this. We can hit second trace, and now you see the x, I hit the value. We can plug in 0.75, and it's going to be our 7.121. Ugh, that's 7.121 is my y value. Okay, we're going to always try to remember to round to 3 places. Now let me show you a quick little other way you could do it. Once you have your function in y1, we have this cool key here. It's called the alpha key. If we want to plug something into a function, we can just go alpha trace, and we get this little building. If you choose y1 and you plug in 0.75, that's going to plug the number into your function, and we get the same answer. So we're going to be using this key a lot next year to make things quicker when we have to. Now that we have the value, use correct units, explain what this value represents. So my value was height in feet. So basically, what this value represent is the knot, right? Because we're talking about the knot in the lasso, is 7.121 feet above the ground. At 0.75 seconds. Notice my units of measure. You have to be careful about that. Now let's look at the next problem. Find the value of h prime of 0.75, and then using correct units, explain what this value represents. Okay, so now I want to remind you. Let's go take a step back for a second. H of t is the height of our knot. H prime of t, right, is the derivative. It's the slope of the tangent line. It's the rate of change of the height of the knot. It's the change in height over the change in time. And because of our units given to us, our answer will be given in feet per second. Okay, so whenever we're talking about a derivative, it's a rate of change. So we want to find the value of h. So the first thing I have to do is I have to go back up to my original function and find the derivative of that function, h prime of t. Now, it looks scarier than it is. Okay, we worked above. This is just my u, right? This piece here just is u. So we're going to have -3 sine u 5 pi over 3t times, now I go in here, u prime. This is my variable, so my u prime is the coefficient out in front. 5 pi over 3. Plus 5, remember the derivative of a constant is 0. So my derivative now, if I simplify this, my 3's are going to cancel. H prime of t equals -5 pi times the sine of 5 pi over 3t. And what we're going to do with this is we're going to plug in 0.75. And we're going to get that value. This one here, I'd probably just plug right into my calculator. -5 pi sine, I'm going to give myself a fraction bar, 5 pi over 3, and remember the number we're plugging in times 0.75, and hit enter, and we get 11 oh, I did something wrong. That should be, this answer should be negative. Oh, duh. This derivative is negative, so this is positive. I'm so sorry, guys. My derivative would be negative sine, so this changes this to positive. What an idiot. I'm glad I'm making mistakes, though, because this really goes to show you how careful you have to be. And I'm going to show you why I knew what my mistake was right away. 5 second pi sine And here your answer is negative 11.107. So that's the value we get. Now, what does this answer mean in the context of our problem? Well, basically, if we go back, right, it's the rate at which the height of the knot is changing. The height of the knot is changing at a rate of negative 11.107 feet per second at t equals 0.75 seconds. And there you have it, okay? So get ready next year to do a lot of thinking and a lot of work, and if you're anything like me, making a lot of mistakes. Okay, signing off. See you soon.